cubic example of finding the derivative using the limit as h approaches 0 of the difference quotient. Again, proper steps, show our work, and so on. The hardest part about the cube is remembering what the cube of x plus h is. All right, you can either look it up or multiply it out. And I'll show you how to multiply it out. All right, so first set it up, though, with the proper notation. So f prime of x is equal to the limit as h approaches 0 of negative 4 times x plus h cubed, and that's kind of, like I said, one of the hard parts, minus negative 4x cubed, the function, all over h. All right, so cubing this out, and then I'm also going to simplify that to positive. I'm going to go do my cube work over here on the side. All right, so x plus h cubed. You can either remember this or look it up. But remember, this really means x plus h times x plus h times another x plus h. And so there's a little more to this than the square. So the first thing is I'm going to multiply 2 of them out. So 2 of them are going to come out. It's going to come out to what we do. This would be the square term, right? And so x squared plus 2xh plus h squared times x plus h. All right, then my next line, I've got to take everything in my first expression, my quadratic, and multiply it by x. And then I've got to do the same thing and multiply it by h. So everything here gets multiplied by x, and everything there gets multiplied by h. And so when I rewrite that out, when I multiply it by x, I get x cubed plus 2x squared h plus x times h squared. All right, there's the x part, multiplied by x, now multiplied by h. Add h times x squared, so x squared h plus 2xh squared plus h cubed. And then the last thing is to simplify like terms. Those are my like terms. So I get x cubed plus 2x squared h, not 2, 3, 2 and 1, 3, and then 3xh squared and h cubed. So either you can remember that's what that cube is, find it, or look it up. All right, but that's what x cubed is. So that's what I'm going to plug in for that x cubed. So again, x cubed plus 3x squared h plus 3xh squared plus h cubed. All right. That's my scratch work off to the side. Now plugging it in my actual function equals the limit as h approaches 0 of, don't forget the negative 4 still up front, so negative 4 times that cube, remember, was x cubed plus 3x squared h plus 3h squared plus h cubed in parentheses. And then I'm changing this from a negative to a positive 4x cubed. Still all over h. All right. I'm going to kind of double check and make sure I've got everything in here correctly. X cubed, 3x squared h, 3xh squared. Okay, I'm good. All right. My next step, distribute that negative 4. So negative 4 is going to get multiplied in. Every single one of those terms gets multiplied by a negative 4. Make sure you're careful. Every single one of them gets multiplied by a negative 4. So you're going to get negative 4x cubed, negative 12x squared times h, minus 12x h squared, minus 4h cubed, plus 4x cubed. Still all over h. Squeeze it in the side of my page here. All right. Now the simplification. That reduces with that, and you'll notice then once those cancel out, you'll have everything left here has an h in it. And so my next step, I'm going to write it as the individual fractions, kind of like we did with the quadratic case. All right, so that's gone. I've got negative 12x squared times h divided by h, negative 12x h squared divided by h, minus 4h cubed divided by h. All right, I'm going to get rid of the divide by h now. So in the first term, those are gone. That's going to leave me with negative 12x squared. One of those are gone, so negative 12x times an h. One of those are gone. And so negative 4h squared. All right, now I'm to the goal, right? I got rid of the divide by h. Now I can solve the limit by plugging in 0 for h. So take 0. There are two h ones, so you're going to plug it in 0 twice. 0 is going to go in here, and 0 is going to go in there. And so when you solve the limit, you get the derivative function. Then that's gone, and so the only thing that's left over is that negative 12x squared, and there's my derivative of f of x. Right, the derivative of negative 4x cubed is negative 12x squared. All right, now we'll use it. All right, use the derivative function to find the slope in the equation of the tangent line at the point 1 negative, and I picked 1 negative 4 because 1 0 is easy. I could pick any other number but 1, but I think 1s are easy because they typically are smaller numbers than really big numbers. All right, so don't think it's always going to be 1. I just chose 1 because it's easy. All right, so first find my slope, which remember is my derivative at the given x value, which is 1. So the slope I'm looking for is the derivative at 1, so negative 12 times 1 squared, so my slope is a negative 12. So it's a pretty big slope. So I'm decreasing very fast. I'm decreasing by 12 units of y per change in x. So slope of my tangent is negative 12. All right, find my equation. Y equals mx plus b. Plug in my point and my slope. So negative 4 was my y. Negative 12 was my slope. 1 was my x. That's a b, not an h. All right, my y-intercept was 8, so my equation is y equals negative 12x plus 8. There's the equation of the tangent line to my function at the point 1, negative 4. Right, I didn't ask you to graph it this time, but you could. You could see that this means it's, and it should. It's fairly steep at that moment, all right? It's decreasing pretty fast at the point 1, negative 4. I'm going to go on, though, and ask some different questions. All right, find the value of the derivative at 0. So the derivative, which we remember is negative 12x squared. So the derivative at 0 comes out 0. What does it tell you about the graph of f of x? Well, that tells me my slope is 0, right? So slope is 0, which means there is no rate of change. At x equals 0, the function, f of x, is not increasing or decreasing. Right? No rate of change. There is a horizontal tangent line. Right? Whenever you get a slope of 0, right, that would be the flat line. That's horizontal. It would be the flat line where there's no growth, right? So the tangent line would be flat. It would be horizontal at that moment. It means the function is neither increasing or decreasing. Typically, what's happening there is it's changing, right? You have a moment where it's going to switch from increase to decrease or decrease to increase, right? That's why it's an important, sort of an important one when we find those horizontal tangents where the slope is 0. All right, the last one. Find the value of the derivative at negative 2. So the derivative at negative 2, so negative 12 times negative 2 squared, negative 12 times 4, and so the derivative at negative 2 comes out negative 48, right, which is a really, really, really big negative number. All right, so what does this tell you? The derivative at negative 48. Well, it tells me the slope of f of x, negative 4x cubed, is decreasing, or is negative 48, which means it's decreasing, right, that's what the negative means, decreasing at a rate of 48 units of y per change in x, if you can read that. And so if we knew what y was, so again, suppose y was profit. All right, so, and with negative numbers doesn't really make any sense, but I'm going to talk about it anyway just because it's just easy to sort of talk about money. So, again, -2 doesn't really make sense with time or anything like that. All right. So, at -2, whatever -2 represents, it's debt. All right. At -2 units of debt, all right, the profit is decreasing, so it's going down. The profit is, we're losing profit by 48 units, $48, when we're in debt, all right, per unit of debt at that moment. All right, that would make any sense. All right, but it just means it's decreasing fast, all right? It's decreasing at a fast speed, all right? I'm going down by 48 units per change in X, so I've got a really big negative slope at that moment, really big decrease. We'll stop there. This is going to be, again, the last of sort of the limits. In the next sections of Chapter 1, we're going to find derivatives of functions using simpler rules where we don't have to use the limit. But you need to know how to do the limit in the quadratic case, and in one of these three cases. The quadratic case, a simple, rational, or a cubic. All right, you have to do at least one of those on the quiz and one of those on the test. All right, so you do need to know how to do that. In the next videos, though, we're going to learn alternative methods to find the derivative besides using the limit of the difference quotient. All right, we'll get those in the next sections.